Hello dear students, welcome back to NEET WORLD. So today we will be discussing very interesting things first of all. See, before starting my session on this question discussion, so today we will be discuss like important topics, okay, important questions actually, okay. So let me show you some important questions so that you will get some clarity like what exactly you need to focus from each chapter. For example, if you look at the PYQs of mole concept, some basic concepts of chemistry we can say right now. So there the questions will be like this, relating the given weight to the number of atoms or number of moles, or giving number of moles to finding number of atoms or number of weight of the substance or volume of that gas occupied. This kind of simple mole concept conversions are asking right now. So this is very important and useful. See what to use here, you just take this conclusion so that you can use this table whatever I am saying wherever the question comes. See, if number of moles are given, let me take pen once. If number of moles are given, okay, so I am indicating number of moles with N. Now if they ask how much amount of substance we have, so simple what to do is you just multiply that with its molar mass. So what to do? Multiply this number of moles with molar mass, therefore you will get the amount of substance, that is weight of that substance. For example, I am saying you 1 mole of carbon dioxide. So what is the weight of this carbon dioxide? It means 1 mole of CO2 corresponds to how much weight? Simple, what to do? You just multiply with its molar mass. What is the molar mass of carbon dioxide? See, carbon atomic number is 6, so 12 plus oxygen 32, so it is 44 now. So 1 into 44, that gives 44 grams of carbon dioxide, that's it, simple. If I say half mole of carbon dioxide, you just multiply half into molar mass, that is 44, means 22 grams, simple now, right. So now sometimes they will give the amount of substance, okay. So it means weight is given, now they will ask number of moles. So just take given weight divided by its molar mass, okay. It means for example 44 grams of carbon dioxide I am giving you. So how many grams or how many moles it is? 44 grams of carbon dioxide I am giving now, divide it with its molar mass. What is the molar mass of this carbon dioxide? 44. Therefore you will get 1 mole. For example, I am giving you only some 22 grams I am giving you. Now how many moles it will be? So given weight is 22 grams, then divide it with its molar mass, that is 44 grams, okay. So you will get half mole of this CO2, that's it. Hope this is clear right now. So like this I will be telling you the very basic things of, basic concepts of physical chemistry as well as inorganic and the next organic. All three like combination of all three parts of this chemistry will be covering, okay. So just focus to the session here itself, focus in this live session till the end, and if you like this content you can share with your friends. And we have started this live discussion for upcoming EAPCET 2026 from past 15 days, okay. So it's been 15 to 20 days that we are discussing the very important topics of EAPCET, both the theoretical part as well as the PYQs related to the concept, okay. Yes, everything will be discussed here, right. You can just use these sessions very effectively and make your preparation more effective, okay. And if you have any doubts, you can just share your doubts in our Telegram group, okay. So the link of the Telegram group will be provided in the description box. Along with that, we have also some WhatsApp groups also. You can join there, you can share your doubts there, our team will respond to that. They will share forward to us, we will respond to that, okay, right. And any queries you just post in that, right, okay. So now look at this. Based on this you can easily solve this question. See, which are the following has same number of atoms as there in 6 grams of water, okay. So how many atoms are there in one molecule of water? See, there is 2 hydrogens, 1 oxygen, 3. So the number of atoms in a molecule is called its atomicity. What is that? Atomicity. So now first of all we need to find number of moles. So after finding number of moles, if it is 1 mole, you can have Avogadro number of particles, 6.022 into 10 power 23 particles. So now first of all we need to find number of moles. After finding this number of moles, you need to multiply with this number. What is this number called? Avogadro number, right now. So multiply with this Na, so that you will get number of atoms, number of entities or particles, whatever it is, atoms or entities, whatever they were asking. Okay. So now again, in order to get this atom, what we are doing, number of moles into Avogadro number. See, if it is water, we will get number of moles of this water molecule. So number of moles into Avogadro number in one water molecule, there are 3, right? That 3, number 3 is called its atomicity. Okay, like this you can write atomicity. Okay, that's it. Okay, so it means if I get number of atoms are given, if you want to find this, same, divide this with this Avogadro number and atomicity, that's it. Okay, right. So based on this, you can able to answer this question. Just look what they are asking, given 6 grams of water and asking how which of the following is having same as this water. See, take the weight of that substance 6 grams now, 6 grams, and divide it with molar mass of water, that is 18 gram per mole. Okay, that's it. It means it is 1/3 mole you got, 1/3 mole H2O you got. Okay, number of moles of H2O is how many? 1/3 mole H2O. Now what they are asking, which of this is having same number of water atoms as in water. See, 1/3 mole, see 1/3 into, in 1 mole of water there will be sorry, so in 1 mole of water we have Avogadro number of water molecules multiplied with what is the atomicity here, 3, right now. So multiply with 3. So you can 3 you can remove, so that you got 1 into Na. This many number of hydrogen, like what atom, like particles, atoms are there in 6 grams of water. Okay. In the same way, we need to verify these options. Verify the option. See, in the first option they given 0.4 grams of helium. So just take 0.4 grams by its mole atomic mass. Atomic mass of hydrogen is 4. Okay, it means you are going to get 0.1 mole. So 0.1 mole is nothing but 0.1 into Avogadro number. So this is not equals to that Na, right? That is 1 Na, this is 0.1 Na. So not this option 1. Just check option C here. So if you take option C, given weight is 1 gram and the molar mass of hydrogen is 2, therefore number of moles of H2 will be 1/2. So you got number of moles of hydrogen molecules. But if I want to check for number of moles of hydrogen atom, number of moles of hydrogen atom is simply multiply this number of moles multiplied with how many hydrogen atoms are there, 2, that's it. So you got 1 mole, 1 into Avogadro number, that's it, we got now. So our option 3 will be perfect answer for this particular question. Okay, so you can verify other options also. See, 1 Na here and 1 Na here, it means option 3 is perfect. You can check, cross check and tell me whether these any of these 2 options will satisfy the same condition or not. It won't satisfy definitely. So if you want, you can cross check and tell me. Okay, right. Let me move forward with few more questions. So now again I will come back to the physical again. See, like this, very first of all you need to understand concept of complete mole concept very clearly. Okay, first you understand this mole concept before entering into the chemistry topics. Any other topics, if you wanted to learn properly, first you need to master this mole concept. Okay, and after doing this, when it comes to organic, so organic and inorganic we have right now. So whether it might be organic or inorganic, you will be learning chemical bonding, right, like hybridization. Okay, right. So you need to look into that concepts also here. See, it's a simple question. Even 10th class student can also answer this, because they will also study about little about hybridization concepts right now. Okay, so now look at this, what they are saying. See, methane is, this is the compound they given. They are asking hybridization of each carbon in the following compound. So what is the hybridization of carbon in each here in this compound? Very simple. See, this carbon surrounded by how many hydrogens? 3 hydrogens now. So it means you can say if there are 4 bonds around a carbon, 4 sigma bonds are there, sp3. Again guys, why I am teaching this today, I mean I can take one specific topic and I can discuss as like the previous sessions. Now why I am taking this is, see, mole concept I have covered. If you haven't watched mole concept my sessions previously which I have made, so you can go and watch them. If you are completely not knowing anything about a mole concept, or this chemical bonding, these things, very basic things, you just go to that previous sessions, I mean previous live sessions for this EAPCET 2026 and you can watch them. Those are highly helpful for your preparation. Okay, so first of all, be clear with some foundations first. Okay, see, foundations are not the negligible part. That is what that includes in the concept itself. See, whenever you start chemical bonding, you need to know this hybridization. It's a part of chemical bonding itself, right now. And see, now I am saying this is sigma bond, this is pi bond. In order to solve this, you need to know what exactly sigma bond and how can we decide hybridization using the sigma bonds and pi bonds and lone pairs. Okay, so when we are saying hybridization, there is no discussion of pi bond. Pi bond does not include. There is involvement of only lone pair electrons and number of sigma bonds. Okay, so like this, if you want to make it more proper preparation, effective preparation, you need to be clear with these basics first. Okay, so now tell me, what is the hybridization of this carbon here? 4 sigma bonds are there, sp3, right? And what about this carbon? It is having 1, 2, 3, so it is simple sp2 carbon. Okay, and what about this 4 sigma bonds, sp3 again? And what about this C triple bond Cn? See, I am going to show you other topics also, just giving you this basic first. Okay, so 1, 2, so 1 is sigma bond here, 2 are pi bonds and 1 sigma bond. Right now this is again sp. So based on this, where do we have the option? See, sp3 or sp2, sp3 again sp. So option 1 will be your perfect answer here, right? If you are not knowing about this hybridization concept and chemical bonding chapter, so you need to must learn and you no need to worry about that. So just go through the playlist of this NEET WORLD YouTube channel itself. So I have covered this chemical bonding for this upcoming EAPCET 2026. Even the last year also I have did, okay, for EAPCET as well as NEET in the same channel. So you can watch either previous videos or this year videos. Okay, right, both are very helpful for you. Okay, next look at this question. When it comes to organic, generally we will start it from very basic, again from IUPAC right now. So I hope you know little basics about IUPAC. Okay, use that concept to name this compound. Okay, look at this. Even if you are a 11th completed student or 11th studying student, you might be aware of this IUPAC nomenclature, because there will be one 2 marks question from this IUPAC nomenclature, right? So tell me, how can you answer? Even if you are preparing for IP, you can answer this. Okay, look at this. Here we have a keto group and one hydroxy group, one double bond and one NH2 group. So which is all these are functional group, but which is more prioritized functional group? Keto, right now. So it means that keto group should get lowest number. Okay, so it means you can number it from this terminal. So this can be 1, 2 and carbon 3 here, 4, 5, 6, like this we can number. So now what is our principal functional group? Ketone group. Okay, if it is principal functional group, that name of that compound should end with that principal functional group, that is oxo or keto, like that it should be. Okay, like on should come at that suffix. Okay, now what are the prefixes we have? 1 hydroxy and 3 methyl and 5 amine. So what is the alphabetical order of these substituents? Amine, A comes first now. Yes, you can write amino as a prefix. First prefix is amino based on their alphabetical order, because amino it means starts with A. This methyl starts with M. Hydroxy starts with H. So which comes first in alphabets? A, right? So A. So 5th position. So 5 amino, and after this, look at the other things we have. Hydroxy, 1 hydroxy and methyl. Which comes first? M or H? See, 5 amino, H comes first now. So then next, here you have 1 hydroxy, 5 amino, 1 hydroxy. Next, 1 hydroxy, 3 methyl, hexane. This is 1, 2, 3, 4, 5, 6 now, hexane. So hexane, and what is the position of triple bond here? 3 now, hydroxy and 3 methyl. Let me write it first. 3 methyl. That's it. Oh, all substituents are over. Now what is the parent chain? 6 carbons are there now. Hex, and what is the position of triple bond? 3. Hex 3 in 3 in, and second position ketone, right now 2 on. That's it. This will be the IUPAC name. So we have, as it is here, option C, that will be your perfect answer for the question. Hope this is also clear. Guys, if the things are clear, just click on the like button. You can share your feedback in the chat box. Like, sir, we are expecting this particular chapter or topic from your side, so that I am going to cover them in the upcoming sessions. Okay, right. Look at this. Look at this. Again, this is a very basic concept from this inorganic. So how can you answer this type of question? See, which are the following compounds, among the following compounds are diamagnetic? Very easy. See, diamagnetic, paramagnetic depends on what? Number of unpaired electrons. If any substance contain unpaired electrons, we can say it is paramagnetic. If no unpaired electrons, diamagnetic. See, NO2 is given, NO is given. Can you answer me this? How can you try this? Tell me. See, when it comes to NO, you just write it. NO means you will be writing it like this. Nitrogen is having 5 electrons. It means 4 electrons are there. One is paired electron and 2 are bonded. One more is unpaired right now. So due to that, I can say this is paramagnetic. Okay, if it is contain odd electron, mostly it will be paramagnetic. Like this, you have NO here, and the next, what about N2O? Yes, N triple bond N I can write, and this is lone pair which can be given to the oxygen. So it will not be a paramagnetic because all electrons are paired here, it is dia. So based on this approach, you can try it for other options also, and let me know your answer in the chat box. Okay, and then next we'll come back to this question, very easy, number of ionizable hydrogens. So how can you answer this? See, just write their structures and you will get this. Okay, we'll come back to this, just hold on, because I need to show you some questions, few more questions which are very easy. First of all, you need to know how to give the oxidation states. See, finding oxidation states also very important. See, for example, they will give something like H2SO4. Okay, what is the oxidation state of sulfur here? Just take X as an atom, which we need to find their oxidation state. Consider X. So 2 hydrogens are there. See, sulfur is more electronegative than hydrogen. Therefore, the bonded electrons are taken by sulfur. So you can write +1, and 4 oxygens, each one -2, like this it is 0. So oxidation state of sulfur here is +6 right now. In the same way, you need to calculate for this bromine here. Okay, in this Br3O8. Okay, so Br3O8 I am giving you. Okay, so what will be the oxidation state? If you do this, you will get it as 3x plus 8 -2 for each oxygen -2 is equals to 0. Then x will be 16 by 3 right now, but there is no such options like 16 by 3. It means, are we doing wrong? No, this is average oxidation state. What is this? This is average oxidation state, but these oxidation states are individual oxidation states. What I am saying? Individual oxidation states. Okay, so how can we get that individual oxidation state? Yes, you can get it from their structure. So what is the structure here? Br, Br, Br. You can write it like this, and after writing, you just insert oxygen atoms equally on the terminal of bromines. Right. How many are left? 2 more are left now. Right. Here 1 more and here 1 more. Okay. And each halogen atom can form maximum of 7 bonds here. I mean here. Okay. So 6 over 7th bond, and this is 7th bond for this bromine. And if you look at this, it is having now one unpaired electron here. Okay. Right. So now this unpaired electron making it to be paramagnetic. Now look at the oxidation states of this individual bromines. See, how many sigma bonds are there? 1, 2, 3, 4. 4 sigma bonds means it is sp3. Okay, you need to check for their hybridization also in order to understand their oxidation state, because if different hybridization, that makes to be having different electronegativities also, because sp having more electronegative, that will have negative charge, and sp2, sp3 will be positive charge, like that. Based on hybridization also oxidation states changes. Okay, right. Look at this. This is also sp3. All of them are sp3 means 6 oxygens are there, so it makes +6. I mean 6 bonds with oxygen, so +6. In between this there is 4 bonds with oxygen atoms, total of 4, so therefore plus 4. Okay, and the next, what about this? Again here plus 6, that's it, plus 6, 4 plus 6. So option B will be your perfect answer for this question. And if you want to cross check whether it is correct or not, just calculate plus 6 we got, plus 4 and the next plus 6, add them. Okay, total number of charges are 3, total number of atoms are 3 right now, that's it. So this is for how much? 10, 16 by 3, that is what we got our average oxidation state. So it is properly indicated one. Okay, option B will be your perfect answer for the question. Okay, next let me show you the previous question that I have discussed here. What they are saying, decreasing order of number of ionizable hydrogen atoms in the following molecules. Very simple, H3PO4 is given now, so you need to first of all calculate its oxidation state. If you calculate here, you will get plus 5 and here you will get plus 3, okay, and here you will get plus 1, and if you do here, so it is minus 12, okay, and this is 4 means 8 is there, so 2 by 2 means plus 4 for each phosphorus, that's it. Okay, hope you got how I am calculating this. See, simple, 4 hydrogens, each one plus 1, 2 phosphorus, 6 oxygens, okay, like this. So 2 phosphorus will be minus 12 plus 4 minus 8, if I send that side it plus 8, it will be 4, that's it, plus 4, like this. It's a very basic one right now. So after doing this, you need to write their structures. For example, I will tell you for this one compound. See, whenever there is maximum oxidation state, that compound will exist in this manner. Okay, maximum oxidation state, maximum number of ionizable hydrogen atoms. How many hydrogen atoms are ionizable here? 3. Okay, so 3 in this first case, and if I look for this, P, P, O, O, okay, and the next OH. See what I am doing, I am inserting one peroxy bond here, so that, let me write it once again. 2 phosphorus atoms are there, and how many oxygens are there? 6 now. So let's insert one over here and one more over here, and OH, OH, like this. How many over? 4 over now, and the next 5th one, 6th one, like this. Okay, there will be how many bonds? 4 bonds, here also 4 bonds, 2 phosphorus over, the next 1, 2, 3, 3 oxygens, 6 oxygens over, 4 hydrogens over, there will be direct PP bond. Okay, now how many hydrogens are ionizable here? 1, 2, 3, 4. So 4 hydrogens, so you can say 4, option C you can see 4, okay, maximum 4 comes from here, 4th option, the next 3 comes from first option, and the next, look at this H3PO3 means how the structure will looks, P plus 3 oxidation state now, so you can write 1, okay, and the next OH, all oxygens are over, 1 hydrogen is remaining because out of 3 we used only 2, that's it, 3. So now how many hydrogens are ionizable? Hydrogens which attach to the oxygens are ionizable, so 2 are there, so here it is 2, and least number of hydrogens will be only 1 for this H3PO2, so that will be here, that's it. So option C will be your perfect answer. Okay, hope this is also clear, right? Let's move forward. Look at this question from organic again. So what they are saying, look, what are X and Y respectively in the following reaction. See, they have taken one normally hexane, 1, 2, 3, 4, 5, 6, 7, heptane they have taken. So this heptane treated with some X, forming some aromatic compounds here. Okay, aromatic compound, that is toluene is formed. So it means simply aromatization. Aromatization can happen with metal oxides. Okay, so especially here molybdenum oxide or chromium oxide can be used. Okay, and after that at high temperatures are required here. Yes, high temperatures and pressures are mentioned. Okay, and after that, say bromination under heating condition if they mention. So just what to do is just replace one of the hydrogen from this carbon, okay, that is what benzylic position hydrogen will be replaced by this bromine. Simply free radical substitution reaction takes place, okay, right. So in that way we have option. Do we have any option here? See here we have, but this is not the one, okay, here it is not the one. See what I am saying, just replace one hydrogen from this benzylic position carbon, CH2Br, that's it. So this kind of option we have only D, that will be your perfect answer for the question, okay. And if you wanted to know and if you wanted to learn this complete organic GOC part and hydrocarbons, you just go through a playlist and you can watch my previous live sessions that I have did for EAPCET 2025, okay, and for 2026 soon we will be starting that session also, okay, right. Next, look at this question, correct order of acidic strength. For the given 4 options you need to give the order of their acidic strength. So which is more acidic, tell me, out of these 4? If you observe phenols, remember I will tell you one simple statement to understand or give the answer directly. Organic acidic strength, organic compounds acidic strength increases by electron withdrawing groups. What I am saying, if electron withdrawing group is present on these compounds, their acidic nature increases, whether it can be phenol, carboxylic acid or any other organic compound. If it contains withdrawing group, its acidic nature increases. If it contains with electron releasing groups, acidic nature decreases. See, we have alkyl group here, therefore it is a releasing group, so it will be the least acidic here, okay. Why least acidic? See, acidic nature means what? This proton should be removed, so that here it will get a negative charge. So this is a conjugate base. If it is more stabilized, then only that H plus ion comes out now. So that stabilization of conjugate base is possible when there is electron withdrawing groups. Again, electron withdrawing group present at ortho or para position will make it more stabilization by mesomeric effect. Therefore, which is more acidic here? 4th one, because nitro groups are withdrawing groups and that is present at the para position. So 4, 3, after this 4, 3, 1 and least is 2, okay. This is the perfect order. So 4, 3, 1, 2, you have option 2 as your answer for the question, okay. Again this is also clear, I hope, right guys, okay. So now can you give me answer for this particular question in the same way, whatever the concept you have learned in this, you just use it on this compound and tell me. Can you answer me? Like consider 1, 2, 3, 4 and they write their acidic nature in the comment box. Anyone can answer me. What's your answer in the chat box by looking at this example as like above. Just what to do, what is the nature of the substituents attached. So if you know that, you can easily answer, okay, right. So I hope you will answer this in the chat box now. Next, look at this question again. See, it's a reagent chemistry. See, they are saying isopentane is taken, treated with KMnO4. So what is the product formed X? That X again treated with dehydration gives a Y major product. So we need to know what is X, then we can say what is the product formed upon dehydration. So simple, you take isopentane structure, okay. So 1, 2, 3, 4 and this is the isopentane, okay. And this one upon treating with KMnO4. KMnO4 is an oxidizing agent, but you know alkanes are less reactive or they were non-reactive towards these oxidizing agents. But if the alkane contains one tertiary hydrogen atom, that will get oxidized to alcohol. See, this is a tertiary hydrogen atom that will be activated and converts into respective alcohol like this, okay. This is a basic thing and first X compound is formed. So this X upon treating with dehydration, like any sulfuric acid or any acid or dehydrating agents you can take, dehydration they are saying. So what happens is, one proton from here, beta position, this is alpha beta na, so beta proton is removed and gives us this one. Okay, we have option A as our answer for the question. Hope this is clear. Right, let me move forward. Again, can you answer me this question? Anyone in the chat box? Can you match this list 1 and list 2? See, benzene treating with chlorine forms some product. What is that product? Simple, just AlCl3 and chlorine is there now. So it will generate an electrophile like chlorine chlorine cation. Okay, so this is an electrophile now. This electrophile will be added to our benzene, like electrophilic substitution takes place and gives chlorobenzene. So A4 we have in 2 options. Next, same benzene with methyl chloromethane anhydrous AlCl3. Again, you just remove this chlorine with this AlCl3, and what is the other part we have? CH3. So CH3 will get a positive charge. It's an electrophile now. That will be attacking our benzene ring and forms methyl benzene, that is nothing but toluene. So B3. So B3 here in option number C, that will be our answer. Similarly, you just check here, AlCl3 and chlorine is there, remove this part and remaining this carbon will be positive charge, that you insert on this benzene ring. So now what happens? One alkyl group is there and phenyl benzene ring is there, so it is a ketone. Alkyl phenyl group, benzene ring, phenyl ketone. So C2 is there, D1, that's it. Option C will be your answer for the question. Okay, next. Again, you can expect a question from this aromaticity also. Okay, can you answer me any question out of these 2? One I will tell you, second one you can do. So always check aromaticity is applicable for cyclic compounds which are having planarity. Okay, complete conjugation should be there, 4n plus 2 pi electron rule should be satisfied. Okay, so I am taking this and you can use this as an example and answer me. See, non-aromatic compound they are asking. See, it will have cyclic structure and conjugative double bonds are there along with this pi electrons, like this non-bonding electrons which can participate in the conjugation. Therefore, 6 pi electrons are there, it is aromatic. Next, this is sp3 carbon now, there is no complete conjugation. So if it is sp3 carbon, no complete conjugation here in this position right now. So it means this is non-planar here, so it is non-aromatic. So your option B will be non-aromatic. Option A is aromatic. They are asking non-aromatic compound, right? Similarly, this is thiophene. Okay, so thiophene also aromatic, same story as option A. Okay, and this is naphthalene, which is having, see, 10 pi electrons are there. Huckel rule is satisfied with planarity and sp2 hybridization. Complete conjugative positions are there here. So this is aromatic. So only B is not aromatic. You can choose B. Next, let me show you few questions. Again, see, when you write the names, IUPAC names, you need to know the priority order now. So based on priority order itself, we have a question in JEE, in EAPCET. So what is the priority order, you tell me? First carboxylic acids, then next sulfonic acid, then next cyanides, then next aldehydes, hydroxy groups as per the given data, right? So option A will be your answer for this question. So that's it. So just believe that your preparation is going well, make it more effective. Okay, so do not have any negative opinions in your mind, just go with positive mindset and prepare well. Okay, so just look at this. If you are unable to solve a question or 2 questions, just skip them, go for the next question. Okay, so just skip that question for that time and you can share those questions with your friends or your teachers or with us. Someone will answer to you, then you can learn from it. Okay, right. Whenever you are facing difficulty with some questions during solving or practicing the sessions, okay, like practicing any questions from any of the topic. So if you face difficulty while solving, so just ignore it for some time. You can do it after some 1 hour or 2 hours, whenever you have free time, again go to it, definitely you are going to solve it. If you are unable to solve, just share it with your friends or someone who can guide you. I mean, someone who can who is like your mentor, or you can share with us. Okay, so definitely you will get your answer. Okay, like that you need to improve your solving skills or ability to understand the new concepts also. Okay, now tell me, what will be your answer for this question? Number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in acidic medium. Again, very basic question from a redox reaction concept. Right, tell me. So ferrous oxalate, you write FeC2O4 plus KMnO4. What happens here? C2O4 converts into CO2 and MnO4 converts into Mn plus 2. So like this I am writing, and ferrous converts into Fe plus 3, ferric. That's it. So this species is completely undergoing oxidation and this is undergoing reduction right now. So now you take this is undergoing oxidation now. So N into N factor, I mean number of equivalents of this ferrous oxalate will be equals to number of equivalents of this KMnO4. That's it. Law of equivalence concept you can use. So right. So what is the N factor here changing? The number of moles of ferrous oxalate we require. So number of moles of ferrous oxalate required for oxidation of ferrous oxalate oxidized by 1 mole of KMnO4. That is 1 mole of KMnO4. See, plus 7 converting into plus 2 now. So what is the number of electrons changed here? 5. So 5 is the N factor of this KMnO4. And this side if you look, ferrous plus 2 converted into plus 3. It means N factor change with respect to iron is 1. Similarly with oxalate it is plus 3 convert into plus 4. So N factor change with respect to carbon here is 1 for 1 carbon, 2 are there, 2 into 1, therefore it will be 2. Total N factor will be 3. So N factor here you can take 3. So now you need to take N is equals to 5 by 3. That's it. So this is nothing but 5 by 3. Yes, directly we have option 4 as your answer. That will be your answer for this question. Okay, next let me move forward with few more things. Look at these questions again. These are from chemical bonding. Okay, so I hope you can answer this very easily. If not, if you are facing difficulty to answer this, just watch my sessions that are which I have done on this chemical bonding for EAPCET 2026. Okay, right. The correct order of bond angles in the bond angles of the following molecules. Like they have given SiCl4, SO3, NH3, HgCl2 given. So tell me, SiCl4 will be having 4 sigma bonds, so it is sp3, and SO3 will be having S, 6 electrons are there. So 1 oxygen, 2nd oxygen, 3rd oxygen. So 3 sigma bonds are there. So you can say it is sp2. Okay, sp2 means how it will be? How it will be? 120 degrees. Now angle is 120 degrees, right? And ammonia hybridization is sp3, 107. Okay, HgCl2 sp hybridization, so 180. That's it. 180 maximum angle. See, more is the percentage of S character, more is the bond angle. You can remember this. More is the bond angle. Okay, so based on this, you can say HgCl2 first, HgCl2, then next SO3. Okay, SO3. After that, ammonia 107, SiCl4 109. So option D will be your answer for the question. Okay, and remaining finding hybridization, finding number of lone pair and bond pair electrons in a given structure, and finding its structure is already discussed. You just try this. If you are unable to answer, just watch the videos on this chemical bonding from my side in this same channel. Okay, and look at this question from Henry's law. This question is from Henry's law solutions. See, till now I have finished complete solutions chapter, clearly discussion of all the important topics like Henry's law, ideal gases, Raoult's law, azeotropic mixtures, colligative properties, everything is discussed. Okay, you can just watch them if you are unable to solve this question again. So look at this, how many moles of methane dissolved in 1 liter of water? See, very simple. Henry's law means how can you take, see, the methane gas was passed into the 1 liter of water, the partial pressure of methane, see, partial pressure of gas that is dissolved will be proportional to the the solubility of that gas which is dissolved will be proportional to its partial pressure. So I can write partial pressure of that gas is equals to, that methane gas will be equals to mole fraction of that gas, solubility I am expressing in terms of mole fraction, okay, multiplied with its Henry's constant Kh. Okay, that's it. So what they mentioned, they are asking number of moles of methane. So find mole fraction first, number of moles by mentioning 1 bar pressure, giving 1 bar pressure, given Kh is 0.4 kilobar, find the mole fraction. Very simple. So bar, bar. So I can write this as 10 by 4 kilo, it means what? 10 into 10 power 3 by 4 will be the mole fraction. See, 10 power minus 3 will be the mole factor, because kilo means 10 power 3 now, I am writing in the numerator, it becomes 10 power minus 3. So this will be 5, 2. So 5 by 2 into 10 power minus 3. This is the mole fraction of methane. So mole fraction of methane can be written as number of moles of methane by number of moles of water plus number of moles of methane, that's it. Okay. So if you observe, this value is very small value, like 2.5 into 10 power minus 3 is very small. It means number of moles of methane quantity might be very small. That's why we got this. So I can ignore number of moles of methane in the denominator, because number of moles of water is very large amount right now, because 1 liter of water is mentioned. So number of moles of methane by number of moles of water is there now. I am sending this water this side, NH2, that's it, done. 2.5 into 10 power minus 3, and you can write given weight is like 1 liter solution is given, considering volume 1 liter and density as 1 gram per ml, so it will be giving weight as 1000 grams right now. So here 1000 grams by 18. So what is this? This will be giving us 55.55 now. So like this, if you take, look at the options, you can write this as 2.5 into 0.55 into 10 power minus 1. So if you multiply this, you will get 1.38, okay, 1.38 into 10 power minus 1, that's it. We have option D as your answer for the question. Okay, right. Let me give you few more questions. Okay, look at this basic redox reaction question from disproportionation. I hope you are aware of these basic formulas, I mean basic definitions of disproportionation, comproportionation, displacement, double displacement right now. So what is the meaning of disproportionation? Same element will undergo oxidation as well as reduction. So look at the options where it is happening. See, it is happening here, phosphorus here it is 0 oxidation state converting into some +1 oxidation state and -3. So this is a disproportionation reaction, and -1 converting into -2 and 0, this is also disproportionation reaction. +1 converting into +2 and 0, this is also disproportionation. But if you look at this, it's not a disproportionation right now. Here calcium +2, here oxygen -2, here also -2, here also -2, +4 carbon, here also +4. This is a simple decomposition, not a disproportionation. So not disproportionation is option 1, right? Right. Yeah. Let me move forward with few more questions. Answer me this one. Very basic molarity based question. The molarity of a solution when 4.9 grams of sulfuric acid is dissolved. And guys, if you are not knowing these concentration terms, definitely you will lose 1 mark in the EAPCET exam, because every year there will be 1 question mandatorily from these concentration terms. Okay, because chemistry will be discussed with chemicals only now. It means we need to express how much concentrated it is. For that purpose we definitely require these terms, okay, especially molarity, molality, normality, mole fractions, these are very important. Okay, right. Molarity, how many grams here they given, number of moles of solute we require first. So that is H2SO4 by volume of that solution into 1000. If it is in ml, it is 250 ml, 250,000, and number of moles we can write given weight 4.9 grams and molar mass will be 98 for this. Okay, so you can just ignore this, and then next this will be 4 times, and this will be how many times? This is 2 times, this is 2, that's it. So what we got here? So 0.2 will be your answer. This is 10 power minus 1 and 2. 0.2, that is option B. Okay, right. Yes, answer this question. And this is ideal solution, identifying if both of them are having same intermolecular forces, it is ideal. See, this is benzene and toluene having same intermolecular forces now, so this is ideal. All of them are not ideal. So for clear understanding of ideal and non-ideal solution, I will definitely recommend my previous video. I mean ideal, so like I have made a special discussion on solutions, complete solutions chapter. Okay, so EAPCET 2026 solutions by me, Ajay Sir. Okay, you just search in the YouTube and you will get complete playlist of this. You can watch it. So this particular discussion which I have made on solutions can be enough even if you are preparing for EAPCET, JEE or NEET. For all exams it will be covered. Okay, you just watch it if you are unable to answer this kind of easy question. See, okay, and tell me what is the pH of this lime water again. See, lime water means basic now. Basic means that whatever the concentration given, that is the concentration of OH minus, not H plus. So this is OH minus ion concentration. That is how much? 10 power minus 2. From this you will get pH as minus log concentration of OH minus, that will be 10 power minus 2, that is minus 2 and plus minus, this will become plus 2. This is POH you got, POH you got as plus 2. Then pH plus POH will be equals to 14 now at 25 degrees Celsius. So pH will be now 14 minus POH, that is 2, that is 12. So option C will be a perfect answer for the question. Okay, hope this is also clear. Right. Can you answer this solubility? Again, one of the very important topic of equilibrium chapter. Even if for JEE, one of the very important topic is KSP, solubility product calculation. Okay, especially finding solubility product for sparingly soluble salts in absence of common ion and in presence of common ion. Very important. Okay, so how can you solve this? Solubility product of AgBr. AgBr is a covalent compound, covalent salt, so it will only dissolve to some extent. If an ionic compound is there like this NaBr, it will be completely soluble in water. So I can say this is a strong electrolyte and AgBr is a weak electrolyte. Okay, so it will dissolve only to some extent, so that's why I am maintaining this equilibrium symbol here. Okay, Ag plus Br minus. Okay, so initially there is no dissolvement of this thing, but after some time t, there will be S amount is dissolved, this salt, I mean this ion and this ion. So therefore at this saturated point, KSP will be equals to concentration of Ag plus concentration of Br minus. Okay, Ag plus into concentration of Br minus, that is nothing but S into Sl, that is S square you got. Okay, and after this what they mentioned, having solubility product this much, but this is happening in presence of common ion. If it is in absence of common ion, this is the story, you can write this KSP and you can solve, but it is happening in presence of common ion now. What is the common ion here? Bromide ion. What is the concentration of bromide ion? 0.2. So S plus 0.2 is the total concentration of bromide ion in the solution. Okay, so these I can write as 0.2. Why I am writing 0.2? I just now told you AgBr is a sparing soluble salt, it will solve very small amount. When we compare that amount with the concentration of this Br ion coming from strong electrolyte, it is negligible. S from this weak electrolyte is negligible. Okay, therefore KSP becomes what? This is S dash and this is 0.2. And what is the value given here? 5 into 10 power minus 10, that's it. Okay, so you can write this as 5 into 10 power minus 10 now. So you can write this as 2 into 10 power minus 1 right now. So it means this minus 1, this minus 10 becomes 10 power minus 9. So again 2 is there, 5 by 2 means 2.5 into 10 power minus 9 is the solubility I can say, okay, in presence of common ion. So there is any option, right? See, we can write 25 into 10 power minus 10. Yes, this will be your answer for the question. Okay, right. Yes guys, if the things are clear, just click on the like button guys, and next you can also share the topics that you are expecting from us. Again, this is based on Le-Chatelain principle. What is the answer you can expect for this? Tell me. See, heat is released. See, during a chemical reaction which is in equilibrium, the forward reaction can be favored. The forward reaction, product formation, see, favorable condition for reaction to occur in the forward direction. So this can be favored when heat is releasing out. So releasing heat from the system decreases the temperature of the system right now. So it means forward reactions are favored by lower temperatures. So you can simply say lower temperature. See, you have option here lower temperature and lower temperature. After that you have gases here. Reactants are gases, products are also gases. See, when we apply high pressure, then equilibrium will shift towards where there is low number of molecules. See, here more number of molecules are there right now. How many are there? This is 1 A gas particle and 1 by 2 B gas particles. So total it is 3 by 2, which is greater than this 1. It means if I apply pressure here, the number of moles of this reactant molecules in unit volume will be increased. Therefore equilibrium moves forward to decrease that. Therefore high pressure favors forward. So this is low pressure maintained, this is high pressure maintained. So that's it. Okay, this will be the perfect answer. Okay, for the same question, if they ask how can we make it backward like backward reaction, what are the favorable conditions for backward, they ask, just take the opposite of these two. See, if forward is exothermic, backward will be endothermic. It means high temperatures are required. Okay, and if forward is favored by high pressures, backward will be favored by low pressures. Okay, so for this particular question, option B will be perfect. If they ask for backward, option C will be perfect. Okay, and then next we have a relation between delta G and equilibrium constant. See, at an equilibrium state, delta G will be 0. Okay, and how can you write this delta G? Delta G is equals to delta G naught plus RT ln Q. Okay, ln Q I am writing. Okay, at equilibrium what I am saying, this is 0, delta G is 0, this term becomes 0. Okay, then standard Gibbs free energy delta G naught will be now minus RT ln K, that's it. This will be the relation. What they are asking, which of the following relation is correct? See, we have here minus RT ln K. Yes, C is the perfect answer for the question. Okay, next. Look at this again. I hope whatever the concept I have discussed in the previous slides, you can use it for solving the questions related to Le-Chatelain principle. Now look at this question. What they have mentioned, they have given the equilibrium conditions for these two reactions. Using these two reactions, this third reaction is made. So what is the equilibrium constant K value for the third reaction they are asking? This K3 is how much they are asking. That's it now. So at temperature T Kelvin, the equilibrium constant for the following two reactions are given below. What is the value of equilibrium constant K for the reaction given? Okay. So K3, how this K3 is made from this 192 equations? See, 2D is there, product side, here only 1D is there. So just divide this equation with 2, that's it. Okay. And the next, here you have 2A, but here only 1A is there. So what to do now? What to do? So divide this equation with again 2. Okay. So that what we will get here? So it will be A plus A gives rise to 1 by 2 B plus 1 by 2 C. Okay. And after this, we are dividing this equation also now. This equation gives B plus C by 2, which is in equilibrium with D. Okay, like this we have. See, and from this net reaction if you consider, the net reaction if you write for this is C by 2 and this C by 2 can be cancelled. And what is the remaining part? A is there, reactant side 1B, this is half B. So here out of this half B will be remain at the reactant side and product formed will be D here. That's it. This is a final equation we got. So now when a reaction is divided with some number, then its equilibrium constant turns to be K1 dash will become now, how much it will become? Just whatever the number you divided, you take it as the power that 1 by n. So 16 power with what number we divided 2 now? So 1 by 2, that's it. So this becomes 16 power root 16 is 4 now, you can write 4. And this is also same manner now. So we did same thing for this also, 25 power 1 by 2 means 5. Okay, so this will becomes 5. So what is the final equation here? I can say K3 will be equals to K1 dash into K2 dash. What is this K1 dash, K2 dash? This is nothing but K1 power 1 by 2 into K2 power 1 by 2, that's it. So this is 4 we got and this is 5, this is 20. So what is your K3 here? 20, that's it. Third option will be perfect for the question. Okay, right. So in the same way, can you solve this question? Okay, yeah, this is a spontaneity process. You can answer me if you know the concept of spontaneity and standard enthalpy formation. Yes, you can try all these questions. This is for you. If you are facing difficulty to answer this kind of questions, you just click on the subscribe button. Stay connected with this NEET World channel. Whatever the concepts we have covered till now, watch them and further sessions will be continued from Monday onwards. Okay, just stay connected. Thank you for watching.